Okay. So the general expression for efficiency is eta is equal to power output to the power input. And power output is AC, that is the AC power delivered to the load, and power input is DC. All right. So P naught AC, in terms of max and min values, you can write V max minus V min into I max minus I min divided by 8 into VCC into ICQ. All right. So that's the general expression for efficiency. So whatever may be the values of Vmax and Vmin, you can just substitute here and you can, find out the expression for efficiency. Okay. Now, let us try to find an expression for maximum efficiency. Because in the previous class, somewhere we mentioned that in case of series fed class A power amplifier, the maximum efficiency is 25%. That is due to the poor impedance matching. And due to class A transformer coupled power amplifier, so efficiency can be increased to, at the maximum 50%. Okay, so let's see how exactly we get an improved efficiency. All right. So in order to derive an expression for maximum efficiency, what I will do is first I will construct the graph, okay, the load line basically. All right, so this is my X and Y axis. Let us place the load line. Okay, so this is basically your AC load line. Okay. Okay, this is some I saturation value, IC saturation value. We do not know what exactly it is. And there was DC load line, and this DC load line was drawn parallel to Y-axis, right? If you remember. So this is your DC load line. And over here you can see, yeah, this was it. The orange line you can see, right? That was your DC load line, because transformer transformer inductance for the flow of DC current is 0, hence you will get very high current. So ideally it is infinity. All right, so the coinciding point basically gives the Q point operation. So that's your Q point, which is VCEQ, comma ICQ. All right. So for maximum efficiency, you know the rule, right? For maximum efficiency, you must allow the maximum voltage and maximum current to appear, right? So let me write down the condition. You could say even this condition as prerequisite. So condition for maximum efficiency, in short, eta max. Okay, maximum voltage and current swings are allowed. Okay, maximum voltage and current swings are allowed. So let us try to construct the same conditions. All right, so what I will do, this is my upper limit for the current flow, and one more straight line. Let's draw from the Q point and the third guideline from the x-axis. Okay, so that is it for my current. And for voltage, okay, let me choose different color. You have to draw one guideline from y-axis followed by x-axis, you'll not get any x-axis guidelines. All right, fine. So now that we have drawn our guidelines, you will be able to plot the waveform now. Okay, you remember, right? This value, this is your VCC, okay, which is equal to VCAQ, and this is your ICQ. Okay, so now let us draw the signals. Current signal, okay, and the voltage. Okay. So this is your Imax, Imin, VC max, or in short, Vmax and Vmin. Okay. Now it is pretty easy to understand that along x-axis, if you see, okay, this is your current axis and this is your voltage axis, right? So basically your Q point, okay, it is, you can say that equidistant point, right? So you have equal distance measured from Q point to this origin. Similarly, you will have an equidistance measured from this Q point till this X intercept. So this is my X intercept. Okay. Since class A power amplifier permits a complete 360-degree cycle, okay, so when a cycle is complete, that is of 360 duration, so probably, I mean, actually this distance, okay, let's say distance A and this distance B are equal. A is equal to B. Okay, the reason is Q point is present at the center of x-axis. Okay, now so here to here is VCC, correct? Here to here it is VCC. Then this Vmax point is present at what value? It is present at 2 VCC value. Okay. So from here to here it is VCC, right? And this is going to be 2 times the VCC value. So this value is basically at 2 VCC. Okay, hope you understood. From here to here VCC, and this is also VCC. So put together the total value going to be 2 VCC. Okay. So therefore, and similarly you can also find out the current value. So from reference x-axis to the central axis, the distance is ICQ. On the other hand, from the reference x-axis to the IC saturation guideline going to be 2 ICQ. Sorry. Right. So for eta max, okay, the condition is I max should be 2 ICQ and I minimum should be 0 amperes. Correct. I minimum is touching the x-axis, hence I minimum is 0. Similarly, on the voltage side, V max, okay, where is its value? Its value is at 2 VCC. And V minimum, okay, is at 0. All right. So now let us substitute. Therefore, eta max is equal to V maximum, that is 2 VCC, minus V minimum, that is 0, into I maximum is 2 ICQ minus I minimum, which is 0, divided by 8 into VCC into ICQ. Okay, so this is V max, this is V min, I max, and this is I minimum. So we have just substituted the respective values. Okay, therefore you would get eta max as 2 VCC into 2 ICQ divided by 8 into VCC into ICQ. So VCC, VCC, ICQ, ICQ. So this is 2 into 2 is 4. So it is 4 by 8 or half. Okay, so that is 0.5, right? So in terms of percentage efficiency, that is percentage eta max is equal to 50%. Okay, so that is what we were claiming in the beginning, that a transformer coupled class A power amplifier gives a conversion efficiency of 50%, which is the maximum. Okay. Any doubts in this? Did you understand?
Yes, sir.
Okay, fine. Fine. Whereas for a practical circuit, the efficiency cannot be 50% because there are losses associated in resistors, transformer windings, etc. So for a practical circuit, the usual range of efficiency going to be 30 to 35%. Okay, so this is the usual range. Okay, but then the efficiency is very poor for a class A power amplifier. Okay, fine. Okay, so now let us discuss the merits and demerits of class A power amplifier. So first let us talk about the merits or advantages. Okay. The first advantage is eta is high. Pardon me for a second. Yeah, eta is high compared to series fed class A power amplifier. Okay. So the second important advantage is that impedance matching. Impedance matching is possible. Okay, due to the presence of transformers. So by wisely selecting the primary and secondary turns, one can match the impedance of the amplifier with the load. Okay, so basically the advantages are those which cannot be fulfilled by a series fed class A power amplifier. So in class A series fed power amplifier, we stated that efficiency is low. That can be overcome using transformer coupled power amplifier. And also we claimed in the disadvantage of series fed class A power amplifier is that the impedance matching is very poor. But in transformer coupled power amplifier, you have the option for impedance matching. Okay, so these are the advantages. And it will also have some disadvantages. The first disadvantage is kind of, the weight issues. Okay, since you are using a transformer, and transformer is a bulky device because it is consisting of transformer core, the primary winding, secondary winding, etc., etc. So the circuit is bulky. Circuit is bulky and less compact. Okay, that's the first disadvantage. And the second disadvantage, since inductor is present, right? It is present in the form of transformer winding, the frequency response becomes poor. Frequency response is poor because the circuit becomes noisy. It gives magnetic hum, you must have heard, right? Whenever you bring your communication device closer to your television set, okay, the speaker starts to give the noise. Okay, so similar performance you can observe in case of transformer coupled class A power amplifier. Okay, and the third one is complicated design. Complicated design. That's because you have to properly design the transformer. If you don't design the transformer properly, then there can be unwanted noise present in the output. Okay, so these are the disadvantages. Okay, all right. So that is about the advantages and disadvantages of transformer coupled class A power amplifier.